already. This is the Chapter 16 exam. I got question 8. Part A says, the siren on an ambulance emits a sound frequency 2.8 times 10 to the 3 hertz. If the ambulance is traveling at 26 meters a second, the speed of sound is 340 meters a second, and the air is still. What is the frequency that you hear if you are standing in front of the ambulance? So we're looking for F front, which is FR, which is equal to the frequency times V minus V of the source divided by, or V divided by V minus V to the source, V minus source. This is equal to 2.8 times 10 to the third multiplied by 340 minus 26, all under 340. And this is going to be equal to, let me get my calculator here. So we have 340 minus 26, 340 divided by that, times 2.8 times 10 to the third power. Now this is going to be measured in hertz because it's frequency. And the correct answer was 3030, but this is what I put in the first time, and it corrected that to that due to rounding and significant figures. All right, part B. What is the wavelength that you hear if you are standing in front of the ambulance? All right, so wavelength, call it FR, is going to be equal to the velocity divided by F, the frequency of FR, which is going to be equal to 340 divided by this, but we'll use the answer in here, right there, which is going to be 3030, which is going to be equal to, let me scroll back down here, this is going to be equal to 340 divided by 3030, it's going to be equal to 0.112, is what we have here. And that's it, measured in meters. Part C. What is the frequency that you hear if you are standing behind the ambulance? So I'm going to notate this one F sub B. And this one is going to be similar to the other one. We have the frequency, and then that's going to be multiplied by the velocity plus the velocity of the source under the velocity. Difference is you're adding instead of subtracting here, which means that this is going to be equal to 2.8 times 10 to the third times 340 plus 26 under 340, which will be equal to 340 plus 26, 340 divided by that, times a 2.8 times 10 to the third power, which equals 2601. We'll round it up to 1. It's going to be measured in hertz, and the correct one was 2600. If you put that in there, it rounds it down due to significant figures and rounding errors. All right, part D. what is the wavelength that you hear if you are standing behind the ambulance? So we're looking for wavelength sub B. Oh, sorry. Wavelength sub B, which will be equal to the velocity divided by f sub B, which will be equal to 340 divided by, we'll use the one that the answer gave us up here, which is 2600, which will be equal to 340 divided by 2600 is 0.13, and call that 131. 0.131 meters, which that is the answer. All right, moving on. Part E. All right, a stationary bagpiper is playing a Highland bagpipe in which one reed produces a continuous sound of frequency 440 hertz. The air is still and the speed of sound is 340 meters per second. What is the wavelength of the sound wave produced by the bagpipe? So wavelength is going to be equal to V divided by frequency, and we'll call that HB for Highland bagpipe, just for notation's sake. So that's going to be 340 meters per second divided by 440 hertz, which is just per seconds. So 340 divided by 440 is 0.77, we'll call it 773. And that will be in meters. And that is the correct answer right there. Part F. F. What is the frequency of the sound wave that a bicyclist hears if she's approaching the bagpiper at 10 meters per second? So we'll call this, oh, sorry. Let me just move some stuff out of the way here. We'll call this FA, just because here it's F approximate, so just FA just to make it easy for us. And that is going to be equal to C plus or minus the V of the receiver, in this case the bicyclist. Apologies, kind of hard to write with one hand and not hold the paper. So if it starts moving around, forgive me. Divided by C plus or minus the V of the source. And this is all going to be multiplied by the frequency initial. Frequency initial being, of course, 440. So this will be equal to 340. Oh, sorry. I'm trying to hold this with my pinky while I write so it stays steady. Plus 10, because the bicyclist is coming at 10 meters per second. Divided by 340 plus 0, because the bagpiper is not moving at all. So they have no velocity. And then this is all going to be multiplied by 440. So we'll have 350 divided by 340 times 440. It's going to be 452.9. 452.9, and since it's frequency, it's measured in hertz. And I have 453, so off by a tenth. It's only an approximate answer, so. Part G. Hold on one second. G. Actually, you know what? I'm just going to turn the paper over now, just to make it easier for us. Okay, G. What is the wavelength of the sound wave that a bicyclist hears if she's approaching the bagpiper at 10 meters a second? So now we're just looking for wavelength. We'll call this wavelength sub A because it is also an approximate here. So just to make it easier notation-wise. Now, this is going to be equal to c over f of a, actually. C is kind of just like the constant velocity. So just to show you right here, the speed of sound, that is what c is. Because c would change depending on the environment. So like if we were in helium, c would be whatever the speed of sound in helium is, and vice versa, just so you understand what c is. Part G, there we go. So since the velocity is 340, and we'll use the answer that they gave us here, which is 453 for our velocity, for our frequency sub a. And then we'll plug that into the calculator here. 340 divided by 453, 0.75, call that 751. So 0.751, that's wavelength, so it's going to be in meters. It's an approximate answer, so 2/100 would be enough. I believe the tolerance is about 1/10, so that should be good. All right, part H. So let's see. What is the frequency of the sound wave that a bicyclist hears if she is moving away from the bagpiper at 10 meters per second? So this is similar to part F. So we'll call F away. It's going to be equal to, it's the same thing, it's 340, but this time it will be minus. Oh, sorry, thumb's in the way. Minus because she's moving away. And again, the bagpiper is not moving at all. So that will just be 340. And then multiplied by the initial frequency, which is 440. So we'll have 330, because 340 minus 10 is 330, divided by 340 times 440, which is 427, call it 0.1, 427.1. That's measured in hertz, which is correct. Now we're moving on to part I. So I. All right. What is the wavelength of the sound wave that a bicyclist hears if she is moving away from the bagpiper at 10 meters per second? So just the same thing here. Wavelength away will be our notation, and it'll be c, the constant of speed of sound, minus divided by f away, which is equal to 340. We'll use the answer given to us in the homework there, which is 427, which, according to my calculator here, will be equal to 0.796. 0.796. Which, again, right here, 23 thousandths. It's not much. It's in meters, my bad. Yeah, 22 thousandths. Tolerance is about 1/10. So part J. Okay. J. All right. A police car is moving east at 40 meters a second. Oh, I'm sorry. A police car moving east at 40 meters per second is chasing a speeding sports car moving east at 35 meters per second. The police car's siren has frequency 1.2 times 10 to the third hertz. The speed of sound is 340 meters per second, and the air is still. What is the frequency of sound that the driver of the speeding sports car hears? Okay. So, it's going to be looking for frequency. I'll use the same notation they have, F away. The formula for this one is going to be constant plus the V of, we'll use S for this, for sports car, divided by constant minus the velocity of the source. We'll use C for car, C. And then S is source, just so we can make it easy for notation, multiplied by the initial frequency. So this will be equal to, our constant is 340, so we have 340. And then we're gonna have plus, and this isn't right. No, it should be minus. I apologize. Should be minus. So it's gonna be 340 minus 35 because they're moving 35 meters a second. Sorry. Divided by, again, 340 minus, and it's going to be 40 because the police car is moving 40 meters a second, and that would be the source in this case, multiplied by the frequency of the siren, which is 1.2 times 10 to the third, and let's do this math here. So 340 minus 35 is 305. Let's clear this up. 305 divided by 340 minus 40 is 300. And then we're going to multiply that by the frequency, which is 1.2 times 10 to the third. And that gives us 1,220. And that will be measured in hertz, which is the answer. Part K. Okay. If the speeding sports car were to turn around and drive west at 35 meters per second toward the approaching police car, what frequency would the driver of the sports car hear? I'll just use F sub t to make this easy to write. And this one would be the constant plus the velocity of the car divided by the constant minus the velocity. Sorry about that. I get pop-ups on my phones. C minus velocity of the source. And this will all be multiplied by the initial frequency. So same numbers, just different signs. Again, sorry, I'm trying to hold the paper still with my pinky. It's a little hard to do this. Minus 40 multiplied by 1.2 times 10 to the third, which will be equal to, all right, let's do this math. All right, so 340 plus 35 will be 375 divided by, again, 300. Which is 1.25, and then we're going to multiply that by 1.2 times 10 to the third, which gives us 1,500. And that will be measured in hertz because it's frequency, and that was correct as well. All right, part L. Let's make sure we have room here. Let's see. For a scene in an action movie, a car drives at 25 meters a second directly toward a wall. The car's horn is on continuously and produces a sound frequency of 415 hertz. Okay, if the speed of sound is 340 meters per second and the air is still, what is the frequency of the sound that the driver of the car hears reflected from the wall? Alrighty. So, we'll just call this F. Just keep it normal. And that's going to be the velocity plus the velocity of the source. I'll just put S for source. Divided by velocity minus the velocity of the source. And then that's all going to be multiplied by the frequency emitted. So I'll put that EM. And that emitted will be the 415 hertz. So, let's see here. So V will be equal to 340, and And then we're adding the source, which will be 25, divided by, again, 340 minus 25, because that's still the source, multiplied by 415 hertz. And that will be equal to 340 plus 25 is 365. 340 minus 25 is 315. And then we're going to multiply that by 415. Get 480. Call it 9 hertz. And the correct answer is 481. So again, plus or minus a tenth for the tolerance. And then part M. All right. How fast would the car have to move for the reflected sound that the driver hears to have a frequency of 495 hertz? So this one's a little different. So we're not trying to find the frequency. We already have it. So we'll have 495 is equal to 340 plus our unknown source velocity divided by 340 minus, again, our unknown source velocity, multiplied by 415 hertz. So now we just have to solve for this part. So divide 495 by 415. 495 divided by 415 is 1.19, we'll call it 1928. So I'm going to make this a little easier. 140 plus resource, 340 minus resource is equal to 1.1928. All right, just allow me to adjust my chair here. All right, so now we're going to multiply the denominator. So we'll have 340 plus velocity of the source is equal to 340 times 1.1928. 1.1928 times 340 is 405.552. Minus 1.1928 V sub S. Okay, now we'll get like terms on both sides, so Vs plus 1.1928 Vs is equal to 405.552 minus 340. And we'll factor out a Vs. That'll turn into 1, so this will be 2.1928, which is equal to, we'll subtract 340 from our previous answer, 65.552. And then we just divide both sides by 2.1928. 2.1928, which gives us 28.9. I'm sorry, 29.9. 29.9. Yeah. Sorry about that. And it says velocity is measured in meters per second, which is the answer. All right. Thank you. Have a nice night.